Hi everyone, my name is Malik Hassan and I am doing my mechatronics engineering degree from Air University Islamabad campus. Today I am going to present my ICT final semester project which is automatic car parking system. So my group members are Muhammad Ali Raza and Muhammad Shahzeb Rafaqat. I spend a lot of time thinking about how machines can make our life little bit easier. So I'm really excited to share my latest project with you, a sensor-based automatic barrier control system. It's more than just a wires and code, but it's a solution for smarter, faster parking system which can be operated through sensors. I have put a lot of work into the logic behind these sensors, and I am proud to walk you through this. So let's get started. Now let's talk about why we are actually doing this. An automatic car parking system is designed to take the work out of parking. So let's think about the traditional way we enter a lot, stopping, reaching out of the window and waiting for a person or a slow machine to react. So we are looking to change that by using a precise sensor technology that knows a car is there before it even comes to a full stop. This ensures that the barrier operates without the driver having to do a- anything. The sensor detects the car and the barrier opens. So the goal here is not to use cool tech. It's about two things, efficiency and safety. By removing the need for human, we make the facility run smoother, reduce the traffic burden at the entrance and create a much better experience for the driver. It's a small but significant step toward the smart cities of the future. So it reduces the manual work to make entry and exit, but the sensor detects the car and open it because when the sensor detects the car, it automatically opens the barrier and which reduces the uh, traffic burden, and it also improves the safety and overall feel of using a parking facility. Now we have to understand why we need automation. We have to look at the problems caused by old way of doing things such as manual barriers. We have all seen the frustrations that come with traditional setup, and they usually boil down to four main issues which are listed below in the slide. First, we have to talk about the significant delays. We have all been there stuck in a long time during morning rush hour just because the entry process is slow. These manual systems create massive and requires more time to process the data in the office hours, which can cause a lot of issues and problems. And it also wastes everyone's time when they are already in hurry. So the second point here in the slide is human dependency, which means that relying on a person to lift every single barrier introduces human variables. People get tired, they make mistakes or something. They just are not have there when you need them. This makes the whole operation unreliable and requires more time. to process it. The third point here is congestion and errors. When things get backed up, it does not just cause traffic, it leads to mistakes, whether it's security slip up or a data entry error. These human movements compromise the safety and efficiency of the entire faculty and cause many problems. The fourth point listed here is automated need. So when you look at all these challenges together, it's clear we need a change. What kind of change? We need a system that is always on and which is reliable and fully automated to keep the traffic moving smoothly and keep the facility secure without the constant need for supervision. So, with the problems of manual systems in my mind, I have designed this project with four clear objectives to make parking smarter, faster, and more reliable. So, the first objective is vehicle detection. So, what does it mean? The first goal is precise, which means that the system is designed to seek exactly when a car is approaching the gate, so it can start the automation sequence immediately without the driver needing to wait or give a signal to the system. The second objective is automatic opening. Speed is key here. Once a vehicle is confirmed, the barrier is programmed to lift very quickly, giving the driver immediate hands-free access to the facility. The third objective is controlled closing. What does it mean? The controlled closing basically means that safety is just as important as speed. We ensure the barrier only lower once the car has completely passed through, keeping the entrance secure and preventing an accidental contact with the vehicle. So the fourth objective is the most important, which is efficiency and manpower. So this is about respect for people's time by minimizing wait times and reducing the need for constant human oversight. We are creating a more efficient system that lowers cost and runs smoother for everyone involved, and it reduces the manpower. So let's talk about the core components of the system. So the first core component is the microcontroller, which is known to be as brain. Every smart system needs a brain, and for this project I used ESP32. Its job is to process all the incoming data from our sensors and tell the rest of the system exactly how it reacts in the real time. So the second core component is the vehicle sensor, which senses the vehicle when it comes in front of it. To see an incoming car, we use the ultrasonic sensor. These are placed at the entry point to detect exactly when the vehicle arrives, ensuring the system never misses a beat. The third component in the circuit, we use a barrier motor, which is known to be a servo motor, to physically move the gate. It's perfect for this job because it provides a very precise and controlled movement, allowing the barrier arm to raise and lower smoothly without any jerky motions. In my circuit, I have used Servo Motor SG90. So the fourth component is the power supply, which is the most important part of whole circuit. So we use 5-watt power unit to make sure that electronics stay consistent and the system is always ready to go when a car approaches the system. So the fifth component is the mechanical barrier. Finally, there is the physical structure itself, the barrier arm and is its connecting wires. This is the visible part of the system that actually secures the entrance and maintains the structural integrity of the gate. So this is the assemblation of my project. This is not 100% completed, but it works. So I have connected a ultrasonic sensor with the ESP32 and I have used a servo motor of model SG90. So basically, ultrasonic sensor sends the signal to ESP32 when it receives or senses the car in front of him. So after when the ultrasonic sensor sends the signal to ESP32, the ESP runs the ultrasonic code and the backup and the give command to the servo motors to open the barrier. So the servo motor uh, operates according to the command given by ESP32 and the barrier opens. So this is the short video which I made for my project. It is it basically shows the working of the project. Look, when I have run the code on ESP32, the code is mounted on the ESP32, and when I have placed the hand on in front of the sensor sends signals to the ESP32, and after that the ESP32 further sends signal to the servo motor, and servo motor operates and opens the barrier. It is basically not much informative, but uh, to understand the concept of the input and output of the coding that I have done for my project. So look, when the hand is placed in front of the sensor, it reads the object in front of him and sends signals to the ESP, and the ESP works and further operates the servo motor. So here you can see the circuit diagram of the uh, circuit I have made, which is known to be as opening and closing of car barrier. In this circuit, basically we have used one servo motor and an ultrasonic sensor, which receives the signal and operates the servo motor. Basically, in this circuit diagram, one wire of servo motor is missing, so sorry for that, but I will give you information for that wire. Basically, the servo motor have three wires. The first one is a red wire, which function is to power the servo motor, and it is connected to the 3-watt pin of ESP32. And the second wire, which the color of that wire is brown, and it is the ground wire which is connected to the ground pin of ESP32, and the third wire which is yellow in my case, but in some servo motors it's orange. So basically this wire is the signal wire, and it is connected to the GPIO pin of ESP32. So in my case, in the circuit diagram, yellow wire is missing. So if you get a servo motor from the market, the yellow wire will be present in that. So remember that the yellow wire is the signal wire which is connected to the any GPIO pin. In my case, I have connected to the GPIO pin 18. So after that, we talk about the ultrasonic sensor HC SR04, which I have used in my case. So basically it have four pins through which it is connected to the ESP32. So the first pin is VCC pin, which powers the ultrasonic sensor, and it is connected to the 3-watt pin of ESP32. And the second pin, which is known to be a triggered pin, basically it triggers the signal and gets or receives the output from ESP32. And the third pin, which is known to be as echo pin, basically it receives or gives the input to the ESP32, and it functions. If we talk about the function, it sends the echo signal. And the fourth pin, which is known to be as ground wire or a ground pin, it is connected to the ground pin of ESP32 Dev module. In my case, I have used ESP32 Dev module, but multiple versions are available in the market, and its latest version is ESP32S3. Basically, the pins are the same on both the ESPs, but a little bit functions vary. But I have used ESP32 Dev module. So it includes the GPIO pins and 3-watt power supply pins and ground pins. It is just like a mini computer. We program it and it perform the functions according to the program we have set into it. So let's talk about the operational flow, that how the system works. So in the first, we talk about the continuous monitoring. The system never sleeps, as you know. The sensors are constantly watching the entry zone, patiently waiting for a car to arrive so it can spring into action. The second point is vehicle detection. The moment a car pulls up, the sensor triggered instantly. It sends a digital hello, a high-speed signal, straight to the control unit to let it know someone is there. The third point is the data processing. Our microcontroller, the brain of the operation, takes that signal and confirms it's actually a vehicle. It processes this information rapidly to ensure the system reacts without any frustrations, delays for the driver. Fourth point, barrier activation. Once the car is verified, the brain gives the order, the motor rotates smoothly, lifting the barrier arm and giving the driver the green light to enter. The fifth and last point is automatic closure. Finally, safety comes first. The system keeps watching until the vehicle has safely cleared the entry point. Only then does it command the barrier to lower, securing the area once again for the next user. So in front of you, I have given you a block diagram of the system. that how the system works. So in the first we talk about the vehicle. Everything starts with the car, as you know. This is the external event the system is waiting for. After that, the system operates. The second part is the sensor, which is known to be as input, as the primary input device. The sensor captures real-time data. It acts like the system eyes, detecting the vehicle and sending that vision forward. The third component is the microcontroller, which is known to be a decision maker or the brain. The information from the sensor travels to the microcontroller. This is where the logic happens. It receives the data, processing it, and decide exactly how the motor should react. And at the last, the motor, which performs the action and opens the barrier. Finally, the microcontroller sends the signal to the motor for the motor movement. This is the physical output where the barrier actually moves to let the driver go inside. So let's talk about the applications. So one of the things I'm most excited about is that this project is how adaptable it is. We did not just build this for one specific garage. The system is designed to integrate into almost any environment where traffic needs to be managed efficiently and securely. Here are four key areas where this technology makes a real difference. In the first, we talk about the shopping complexes in busy retail hubs. Keeping traffic moving is essential for a good customer experience. This system manages high volume entry and exit without the need of for a huge staff presence. In the second, the offices premises. So for corporate offices, security is the main priority. Or automated barrier ensures that only authorized employees and pre-registered visitors can gain access, providing peace of mind for the entire building. In the third, the most important is the university campuses. As we know from our own experience here at Air University campus, parking can get crowded fast. This system helps streamline the flow of students and faculty, making the morning commute much less stressful. And at the last, the private residential areas for apartment complexes or gated communities. This adds an extra layer of safety and convenience for the residents. Residents basically don't have to wait for a guard. The system recognizes them and let them go home securely and safely. So let's talk about the advantages of automation. After looking at how the system works and where it can be used, it's clear that the shift from manual to automatic brings some incredible benefits. This project is not just about the technology, it's about making everyday life easier through four main advantages. The first advantage is fully automated, the hands-free experience. First and foremost, the system is completely designed which senses the car and the barrier opens. By removing the need for anyone to physically lift a lever or push a button, we provide a seamless, hands-free experience for every driver entering or exiting the lot. And at the second, we talk about the time and effort saving, giving time back. We have all felt the stress of being in a hurry. The system significantly slashes vehicle waiting times, meaning driver get where they are going faster, and the mental effort of managing a gate is completely removed. And at the third, the reduced manpower, which means smart resource management. From a business perspective, it is optimizes operational cost by automating access point facilities no longer need to have staff dedicated to barrier management, allowing them to use their team for more important tasks. So at the last, we talk about the cost effective and reliable. So finally, this is a long-term solution because the system is durable and requires very little maintenance compared to manual labor. It delivers major savings over time while remaining a dependable part of the building's infrastructure. So let's wrap things up. I would like to share where this project stands today and where I see it going in the future. So basically, this project is successfully shown that by combining simple sensor technology with microcontroller intelligence, we can create a highly effective automated barrier system. It's more than just a technical exercise. It's a working proof of concept that ensure a safe, efficient, and most importantly, exceptionally smooth experience for every driver entering or exiting a facility. So let's talk about the future scope. While the current system works great, there is always a room to make it even smarter. To make this to the next level, I have identified three key areas for enhancement. So in the first, we talk about RFID. We envision adding radio frequency identification to allow authorized vehicles to enter even faster and more securely. And the second, number plate recognition. By integrating cameras, the system could automatically identify vehicles by their number plates, which should be a huge boost for security and record keeping. At the end, we talk about the mobile application integration. So finally, we love to put the power in the driver's hand. Developing a comparison app would allow user to check parking status in the real time, make reservations, and even handle payments right from their phones. So this project is just the starting point of creating truly smart infrastructure that respond to our needs. So in conclusion, this project successfully demonstrates that by combining sensor technology with microcontroller intelligence, we can create a parking experience that is safer, faster, and remarkably smooth for everyone involved. But this is just the beginning. Look ahead, we envision transforming this system into fully connected smart hub by integrating RFID for secure access, number plate recognition for automated record keeping, and dedicated mobile app for real-time reservations and payments. We are truly redefined urban mobility. So thank you for your time and for watching this video. I look forward to seeing how these innovations continue to shape the future of our infrastructure. Thank you. Allah Hafiz.